Hey there, Year 11s, Mr. Herman here. This video will be looking into the first exam, the non-calculator exam for math methods. This was exam 1 with reading time of 15 minutes and writing time of 1 hour. 8 questions, number of marks for this one was out of 30. We'll jump straight into the process of how to tackle these questions, including the allocated marks for each question, and also what it was expected for you to do. So pretty much a process. So question 1, nice easy one to start off with. Solve the equation 2 log base 4x minus log 418 plus log 42 is equal to 0. Now, quite a few people didn't realize that you just had to use basic log laws in order to tackle this question. And a lot of people forgot a few rules of how to approach this. I can see that this is 2 log here, 2 in front of the log. If we just look at this 2 log base 4x, I can put that 2 as a power here. And because all of these bases are the same, they're all 4, we can manipulate this in such a way where it only reads as just 1 log. So now I'm going to rewrite this as log 4 of x squared. So I've just put that 2 to the top, and everything else afterwards still remains the same. So log 418 plus log 4 of 2 is equal to 0. Now there's a little thing here that says x has to be greater than 0, and you'll see why this is the case. It has to do with getting or obtaining an x squared. We'll get to that in a second. Now that we've got all the bases the same of being 4, whenever you see 2 logs being added together, whatever is inside the log gets multiplied, and whenever you see a subtraction happening, whatever you see within the log gets divided by. So since this is going to be all the same, this is going to be log base 4. We have an x squared and we have a 2, and because this is adding together, these things within the log get multiplied, so this is 2x squared. And we also have a subtraction, so there is a divided by 18. So I've just combined all of these logs together with the log rules that we've looked into already, and this whole thing is going to be equal to 0. And the reason why I wanted to group everything together is now we can change this from log format to exponent format. A base here is 4 and a power is 0. So remember, this here will be the power of what it's equal to, and this here is the base. So in other words, we can rewrite this as 4 to the power of 0 is equal to simply whatever is in here. And this can be simplified to just x squared over 9, because the 2 and the 18 simplify to 1 over 9. And 4 to the power of 0, or any number to the power of 0, is equal to 1. So I'm just going to rewrite this as x squared over 9 is equal to 1. Just flip this around. 4 to the power of 0 is equal to 1. Now I just multiply both sides by 9 and square root both sides to get x is equal to plus minus 3. But because x has to be greater than 0, we can only take the positive answer for this. So since x is greater than 0, x is equal to 3. So this is the approach to get your 2 marks. Question 2, 2 marks as well. Given x is attached to the function h such that h of x is equal to 1 plus 2 to the power of x, we're going to sketch h of x on this axis below. And we're also going to label the asymptote with its equation and any axis intercepts with the coordinates. Now a normal exponential looks like this, so it doesn't hit the x-axis, and because there's this 1 in front of it, this could also be just written as 2x plus 1, it's the same thing. That bumps the normal exponential graph up by 1. So your normal asymptote will be at y is equal to 0. Because this is bumped up by 1, the asymptote will now be at y is equal to 1. So everything just gets shifted up by 1 unit. And before we get to this, we need to find out that obviously there's not going to be any x-intercepts. We are going to look for any y-intercepts, and this occurs when x is equal to 0. Or in other words, we're trying to find what h of 0 is. And this is just a straightforward substitution. Any number to the power of 0 is equal to 1. So this is just 1 plus 1, which is equal to 2. So when x is equal to 0, y is equal to 2. And that's going to be our intercept for y. So this is just going to go up to 5. We have 1 and 2. These two numbers are important because at 1 is going to be the asymptote, which is here. So the graph doesn't touch this. It just keeps on going in the negative direction forever and will never touch. And our corresponding y-intercept is here. So your normal exponential is going to scooch up, hit your y-intercept, and it's just going to keep going this way. Here, this is at y is equal to 1. This here is your intercept to 0. Label the asymptote with its equation. So that's the equation. And any axis intercepts, which is this. So here, this is my h of x is equal to 1 plus 2x. So you had to show this and also this asymptote and also show the graph correctly inputted onto the set of axes. Now question 3 out of 5 marks, broken up into 2 marks for the first question and 3 for the second one. B was a bit of a tricky one to approach because it's a mixture of both rate of change, average rate of change. Average rate of change using the formula y2 minus y1 over x2 minus x1, not obvious. The first, we'll tackle this question here. Now, it was stated within class that you had to remember your set of table of graphs for exact values. And there's a few clues on how to approach this question. For those who got the answer correctly but used degrees instead of radians, you lost half a mark. Because x is an element of 0 to 2 pi, and that 2 pi specifically, I'm expecting answers in radian format, not degree format. Because if I wanted answers in degree format, this would say x belongs to 0 to 360 degrees. And whenever you tackle a question that looks like this, always draw your unit circle. It's just a go-to, it's a good visual to understand what it is you're exactly looking for. Always label in all stations to cram in. And this is saying that cos of x, so x being the radians or the degree that we're looking for, is equal to square root of 3 over 2. So the square root of 3 over 2 is going to belong somewhere over here. It's right there. And because this here is positive, we are also going to look for the quadrant that's also positive that belongs to cos, and that's the fourth quadrant, which is here. So this is saying when the cos is attached to x, so x is equal to cos. So this is saying cos of whatever the angle is, the radian. So this is saying there are 2 points within this unit circle that is equal to square root of 3 over 2. This point here and this point here. And what we need to look for is what this angle within here is equal to, and then also what this angle here is equal to. So x is in the first and fourth quadrant. So x is in first and fourth quadrant. And because of this, whenever this is equal to root 3 on 2, this is when you're going to rely on the table. You are going to state that x is equal to pi on 6. Okay, so root 3 on 2 associated with x is pi on 6. So that little angle in there is pi on 6, or also 30 degrees. Now some people wrote 30 degrees, which is correct technically, but incorrect with this approach because it says x is an element of 0 to 2 pi. So we need the answer in radian format. And also, because we're also looking in the fourth quadrant, x is also going to be equal to this part here. Now, how we get that is getting 2 pi, so a full revolution, which is 2 pi, take away that pi on 6. Because that little angle in there is also pi on 6. There's this inverse that's happening on, or a reflection that's happening on the x-axis. So this is 2 pi minus pi on 6. So in other words, 2 pi is also the same as 12 pi on 6. So since 2 pi is equal to 12 pi on 6, we are looking for 12 pi on 6, take away another pi on 6, which results in 11 pi on 6. So x is equal to pi on 6, and 2 pi minus pi on 6. So this is where we get 11 pi on 6. So those are the two solutions here, which will grant you your 2 marks. Some people put 30 degrees and the other one was 330 degrees. Again, technically correct. You'll get 1.5 marks for that one, but I have to see it in radian format. For question B, if f of x is equal to cos of x, find the average rate of change of f of x between x is equal to 0 and x is equal to pi on 3. Now this one wasn't obvious about how to approach this, but most of the part of the formula that you need to use has been given to you. You just have to, again, rely on that table to work out other two values. So first thing we need to use is we have a gradient, which is going to be equal to y2 minus y1 over x2 minus x1. Whenever you see average rate of change, you know that this is going to be our template formula. Now the second thing we also know is that x2 and x1 has been given to us already based on these answers here, or these x values here. And this one here, the x is equal to pi on 3, this will be our x2, and this here will be our x1. So we've already got our x2 and x1 that we can put into a formula, but then we also have to find out the respective y2 and y1 values. And y has been attached to this f of x, which is cos of x. So in other words, we need to first find cos of pi on 3, and also cos of 0, because then this will give us our y2 and our y1 respectively. So cos of pi on 3, referring to the table, is going to be half, and cos of 0 is going to be 1. So we have a y2, y1, we have our x2 and x1, and all we have to do is just simply substitute this. And there's going to be a bit of fraction manipulation to get the solution. Y2, in this case, is half, minus y1, which is 1. This is obviously going to be an ugly fraction. This is going to be equal to pi on 3, take away 0. And this here is your m. And if you've got this right here, that will give you the 2.5 marks. To get that extra mark, you just have to simplify this so we get a proper solution. So this right here, half take away 1 is equal to minus half over pi minus 3, pi over 3 rather, minus 0 is just pi over 3. So now we have a division of two fractions. So remember, we can write this as half divided by pi on 3. Let's just modify it in a way so we can do our keep, change, flip. Keep the first fraction, change this to a times, and then flip the second fraction like so. So our full solution is minus 3 on 2 pi. And that right there is your average rate of change from these two x values, 0 and pi on 3. Question 4 out of 6 marks, 3 questions, A, B, and C. We have f of x is equal to 3 over x to the power 4 minus 5x to the power 6, where x cannot equal 0, and we have to differentiate this. Before we can differentiate this, because we have this x to the power 4 on the bottom, I'm just going to rewrite this in a format where I can apply my rules of differentiating as so. So all I've done is taken the x that's on the denominator and put a negative power, because it's effectively the same thing. The reason why I do this is because when I work out f dash x, or the derivative, I take my power, put it to the front. So negative 4 times positive 3 rather is negative 12. And then the power here gets subtracted by 1. So this will be x to the power of negative 5. I've seen a lot of people put x to the power of negative 3 remember you're subtracting 1, and you got to just be careful with your negative numbers. In this case here, 6 jumps to the front, so 6 times 5, so this gives me minus 30x, and then subtract the power by 1. And if you want to write this in a proper format, you can just do minus 12 over x to the power 5. Some people left it in this format here, and other people left it in, or put it in the proper format. Either way, you'll still get the 1 mark. Second question, we have h of x is equal to 2x minus 3 in bracket, x plus 1 in bracket. We have to evaluate h dash negative 1. Now, a lot of people fell into this trap of putting negative 1 into this formula here and then just evaluating h of x. We are looking for h dash of negative 1. So we need to find the derivative of this first and then find out what the rate of change is at negative 1. Okay, because we're looking at h dash. So that dash makes a difference. Before we can do that, h of x is in a format where I can't necessarily differentiate, so I'm going to expand it. So 2x times x is 2x squared. 2x times 1 is 2x. Minus 3 times x is minus 3x. And minus 3 times positive 1 is minus 3, which can then be further simplified down to 2x squared plus 2x minus 3x is minus 1x, and then minus 3. We can't tackle h dash of negative 1 without getting h dash of x first. So differentiating rules, 2 jumps to the front and subtract the power by 1. So that's just x to the power 1, which is leave it as x. And this here, this is minus 1. So there is technically a 1 there that jumps to the front, and then that gets subtracted by 1, the power by 1, so x to the power 0, which is 1. So it is just negative 1 times 1, which gets you 1. In constant, you just disregard. Now we can evaluate h dash of negative 1, which is just 4 times negative 1 minus 1, or negative 4 minus 1, which gives you your negative 5, which is here. The third question that's associated with question 4, worth 3 marks. And we did an example like this within class where you had to evaluate the instantaneous rate of change at both x-intercepts. So there's a few set of steps that you need to do in order to tackle this question linearly. So the first thing we need to do is we have to find where the x-intercepts occur. So x-intercepts occur, and this occurs when g of x, or y, is equal to 0. So in other words, x squared minus 2x minus 63 is equal to 0, and we need to find out what the x values are to make this equal 0. Now, we can see here that we need to find two numbers that when multiplied together will give us negative 63, and then when added together will give us negative 2. Those two numbers are minus 9 and plus 7. So rewriting in this way, factorizing will get us to this point, and then we can use our null factor law to get x minus 9 is equal to 0, or x plus 7 is equal to 0. Therefore, x is equal to 9, or x is equal to negative 7. So we've got our x-intercepts, which is awesome. Now what the question is asking for is that we're going to get the instantaneous rate of change at these x-intercepts. So I need to get the rate of change function. So I need to find out what g dash of x is before I can substitute these two values in. So g dash of x is just simply 2x minus 2. That's it. 2 jumps to the front, and minus 2. The negative 63 is a constant, so we disregard. And then we can evaluate. We can find out what g dash of 9 is, and also g dash of 7. Negative 7. So g dash of 9 is equal to, just substituting this into here, 2 times 9 is 18, minus 2 is 16. So g dash of 9 is 16, and g dash of negative 7 You substitute this into here, minus 7 times 2, negative 14, minus another 2 is minus 16. And remember in class we said that because of the symmetry that happens with this set parabola that looks like that, no matter what 2 points you use, say for instance our x-intercepts are here, I don't know if this is correct, but if our x-intercepts are here and here, that rate of change that happens between there and there have to be the same number, but one's going to be positive and one's going to be negative because of that symmetry that happens. And you can choose any 2 symmetrical points, get the rate of change. That rate of change number, they're going to be digit-wise, are going to be the same, but one's going to be positive and one's going to be negative. So this here is negative 16 and this here is positive 16 at these 2 intercepts of 9 and negative 7. Question 5, 3 marks, probability, and it was interesting to see the approach that some of you guys had when it came to this. What I did to approach this is I did a 2-way table, and then once I did the 2-way table and filled in as much information as possible, everything else just laid itself to tackle these questions. So it was good to see that some people did this as well. So you have your A and A dash, and then you have your B and B dash, and then this was split up as normal, and then we have to fill out as much as this terrible angle, but that's okay, as long as I get my results and they're correct, I can use them accordingly. That there in the right hand corner has to equal 1. And I'm going to put these fractions out of 10, even though some of them are in fifths, but I'm going to put it to 10. Okay, so events A and B for the sample space. The probability of event A happening is 3 out of 10, or 30%. The probability of B dash, not B happening, is 2 out of 5, or 4 out of 10. And the probability of union, A union B, is 7 out of 10. Now, just in case, for visual sake, that's A and that's B. A union B is everything in that middle there. A and B is just that intersection. So let's fill out what we can. The probability of A happening is 3 out of 10. So regardless of whether B happens or not, over here we have 3 over 10. And also the probability of B not happening is 2 out of 5, or 4 out of 10. So the probability of B not happening is 4 out of 10, 2 out of 5. Now, we can also determine what this is here by just getting 1 take away 3 over 10. So that there is 7 over 10, meaning this here has to be 6 over 10. Now, some students got up to this point and then got stuck because they knew they had to use this somewhere. They just didn't implement it properly within here. Now, to do this, we know that probability of A union B, which is everything all together, is 7 over 10. Okay, so everything. So if you're in A or in B or in the middle, there's a 70% chance, probability of me obtaining someone within there. Meaning that the outside, which is this part here, must add up to 1. So that's 7 over 10 plus whatever this is here must add up to 1. And the outside is A dash and B dash. So the outside is A dash and B dash, which is 3 over 10. Because 7 over 10 plus 3 over 10 is equal to the 1. So A dash and B dash here is 3 over 10. And once you figure that out, the rest you can work out. So let's put in, and I'll choose another color from here. Let's go light blue. We have got 3 over 10. So this here is 4 over 10, meaning this has to be 2 over 10, and that has to be 1 over 10. And all the maths adds up. So now what we need to find is the probability of A and B. So what that middle part is. Now a lot of people use the different rules where probability of A union B is probability of A plus probability of B, take away the intersection. You could use that. But this way it's just much easier once you've figured out this main one here. So the probability of A and B, this here is just simply equal to 2 over 10 or 1/5. And then using that table, find the probability of A dash and B dash, so not A and B. You can think of this as 1 minus probability of A union B. So it's the inverse or the opposite of everything that's within here, so the outside. And we've already worked that out, which is just that 3/10 here. But the maths for that is just 1 minus 7 over 10, which is equal to 3 over 10, which is what we've got here. Question 6, the one that stumped quite a lot of people. Actually quite a simple question based on this clue here. So the question, the volume V in centimeters cubed of a cone is given by this formula, where R is the radius in centimeters and H is the height in centimeters of the cone. Now the radius and height of the cone must sum up to 15 centimeters. Because of this little fact, you have to prove or show that the volume formula can be rewritten in this format. And you notice that the letter H has been taken out or replaced with something, and it has to do with this here. So what this clue is implying is that the radius and the height must sum up to 15. R plus H is equal to 15. And we don't know what the R and H is, the radius or the height. We know when added together is going to equal 15. Now, if you look at this, you've got to clue in. There are no H's. I've got to replace H with something. So I'm going to manipulate this formula and say that H is equal to 15 minus R. I'm going to subtract R from both sides. And with that in mind, if I subtract R, cancel. This is just going to be equal to 15 minus R. And then what I can do is then substitute H into the original formula and replace it with 15 minus R. So my volume is equal to 1/3 of pi R squared, but instead of writing H, we're going to write 15 minus R. So that eradicates the H. That's gone. And this whole thing here, this whole thing is just a term. It is just a term. So we can apply expansion rules to this. So our volume is equal to 1/3 pi R squared times 15. That 15 will just be multiplied by the 1/3. And 1/3 of 15 is just 5 pi R squared, which is where that 5 comes from. Minus 1/3 pi, now R squared times R gives us the R cubed, which is what we see here. Now this is just rewritten in a different format. They've got the 1/3 in the front, but effectively it's just the same as writing pi R3 all over 3. And that is the proof. That's the 3-step process that you need to do. Some people got stuck on this. Some people got fixated and substituting different R values and H values. No, there's a clue here, specifically right here. And once you clue into that and rearrange H, the rest will just write itself. Question 7 out of 4 marks. Consider the function f of x is equal to 4 times the square root of x plus 2. Part of the graph of this is shown below. And we need to show that the point P of 0, 4 does not lie on the graph. So in other words, they're trying to say that that point there, when x is equal to 0, that y point shouldn't equal 4. It can't equal 4. It's going to equal something else. So what you need to do to tackle this is you need to simply just substitute 0 into the formula. And if our result is 4, cool. But we're expecting the result not to be 4 because it's saying that we have to show that this is not on the graph. So f of 0 is equal to 4 times the square root of 0 plus 2. And many students at least got this approach correct. Now the square root of 0 is just simply 0. So this is just 4 times 0 plus 2. 4 times 0 gives me 0. So 0 plus 2 gives me 2. which does not equal the 4 as we expected. And that's all you have to write. As because we get 2, and this doesn't equal 4, therefore the point 0.04 does not lie on the graph. Oops. There we go, it does not lie on the graph. That's all you need to do to prove that one. But the next question stumped quite a lot of students because there was an approach to it logically, which quite a few students didn't, and I still gave a mark for it, but it's not the approach that I was expecting. There is going to be a differentiation that's involved, and we've vaguely touched on half powers, or x, finding the square root of x, the derivative of that, if that's in there. So the point Q is on the graph. We have a gradient on the graph at that point Q, which is equal to 1. We need to show that Q is the point 410. Now, a lot of people looked at this here and they said, okay, 410 has to be on the graph, so I'm going to substitute 4 into my initial, let's just write the function here, for f of x is equal to 4 square root of x plus 2. And what students did, or most people did logically, and I don't blame you, is put 4 into here, get 4 times 2, which is 8, as the square root of 4 is 2, 4 times 2 is 8, plus 2 equals 10. You think, oh yeah, sweet. Yep, so 410 is a point on there. If they wanted you to do that, this little fact here becomes redundant. So you have to think, okay, the gradient of the graph of that point at Q is equal to 1. I need to get a gradient of some sort. I need to get a rate of change, or instantaneous rate of change. So if my f of x is equal to, and I'm just going to rewrite this as 4 to the power of x, 4 times x, to the power of half, plus 2. Then I can apply my differentiation rules to get f dash of x, and then just apply my rules as normal. Put the power in front, so 4 times half, which gives me 2. And subtract 1 from the power. So half take away 1 is minus half. And that plus 2, not needed. This can then be written as 2 over the square root of x, because that minus, we can write it to the bottom, which is just x to the power of half, and then it's on the denominator, but then x to the power of half is the same as the square root of x. So this is just 2 over the square root of x. Now that we have this is saying that my f dash of x, the gradient, is equal to 1 at the point Q. So we've already worked this out. 2 over square root of x is equal to 1. And what we need to do using this fact is find out what x is equal to. And we're hoping that somehow we get to 4. So what we'll do to attempt this is we want to solve for x. So we're going to multiply both sides by the square root of 2. Again, this is not an obvious approach because of that little fact. But the mathematical approach to it, the arithmetic anyways, and the algebraic side is actually quite simple. Sorry, this is a square root of, not square root of 2, sorry, square root of x multiplied by square root of x. So that will cancel out with that. So we have 2 is equal to 1 times the square root of x. Then we can just go ahead and square both sides to cancel out the square root. And what we'll end up is, I'm writing sideways quite a lot, apologies for that. 2 to the power 2 is 4 is equal to x, which is what we wanted in the first place from this fact here. And now that we know that x is equal to 4 is a point on the graph, because the rate of change when it's equal to 1 has to be at 4, we can then just substitute x is equal to 4 into the original graph. So then we're going to find f of 4, not f dash of 4, because f dash of 4 will find the gradient at 4. We don't want the gradient at 4. We now need to prove that 4 is a point on the graph. We need to prove that 10 is its respective y value when x is equal to 4. So find f of 4. So f of 4 is just equal to, that's 4, sorry, no, 9. F of 4 is equal to 4 times the square root of 4 plus 2, which is 4 times 2 plus 2, oops, plus 2, try that again, which is a plus 2, which is equal to 10. And you can say, therefore, 410 is a point. Q. 410 is a point on the graph. So, not an obvious approach. You've got to think logically, and the reason why this type of question has been thrown into the exam is because you're going to get these curveball types of questions in the Year 12 exam, where the math side to it is easy, but you've got to think logically. Why do they put that point in there? Like that little fact. They have to somehow use this. We have to somehow use this to tackle the question. All right, last question. Question 8. Quite a few people got this correct, which is good to see. We have a particle moves in a straight line so that its position x centimeters in relation to a fixed origin at time t seconds is given by this specific formula here. We need to differentiate x with respect to t, which is 2 marks, and then find these turning points. We'll get to that in a second. So for now, differentiate. So if my x of t is equal to 3t to the power of 4 minus 16t cubed plus 18t squared, then to differentiate this, easy, drop the 4 to the front. This is 12 and subtract the power by 1. 12t to the power 3 minus 16 times 3, which gives me the 48t squared plus 36t. So many people got this process correct. Now this is weirdly this is 2 marks, even though there's quite a easy 1 mark process. So if you didn't write x dash t is equal to, or wrote something completely different, but you still got this correct, you just get that 1 mark there. But the second approach to this question, the turning points of the graph occur when the rate of change is equal to 0. You're going to find the 3 times this occurs. So remember, the rate of change is the tangent, okay, the tangent line. And what it's saying is at 3 specific points, and we can see these points. It's not obvious for this one here, but there's actually one here. There's one here, and there's one here. That line that we create, that tangent line, is equal to 0. So what this is saying is that the rate of change is equal to 0. We need to find the 3 times that this occurs. So this is implying that this rate of change, which we've already found out, t, 12t cubed minus 48t squared plus 36t, this rate of change, when this is equal to 0, we need to find the 3 different times that t occurs. Alright, so we need to find where those 3 spots are. Now you look at this and you think, yikes, there is a cubic that's involved. What's going on here? Well, in order to tackle this, we can take out 12t as a common factor. So let's take out 12t as a common factor. And what we have left is t squared minus 4 letter t, not 40, 4t, letter t, plus 3, and this here is equal to 0. Now I can go ahead and divide each side by 12t to get rid of it, but I'm not going to do that. I'm actually going to keep it there because it's asking for the 3 times in which this occurs. So I'm just actually going to leave this there. This here can be simplified. We're looking for 2 numbers that when multiplied gives me positive 3 and when added gives me negative 4. This occurs when t is equal to negative 3 and t is equal to negative 1. Negative 3 times negative 1, positive 3, minus 3 plus minus 1, minus 4. This here is equal to 0. And then we can use our null factor law to imply that 12t can either equal 0 t minus 3 can equal to 0, or t minus 1 is equal to 0. Which implies that t is equal to 0 if we divide both sides by 12, t is equal to positive 3, or t is equal to positive 1. So these 3 points at 0, 1, and 3, my gradient is equal to 0. So these are the 3 times at which this occurs. Now, it's asking for the 3 times. If it asks for the 3 coordinates, then you would substitute 0, 3, and 1 into the original equations to get the associated coordinates: 0, something else, 3, something else, and 1, something else. But it's not asking for that. It's not asking for the coordinates, so you can just leave it as 0, 3, and 1, and you will get 1 mark for each one. A lot of students just gave me 0 as one of them, which you still get a mark for it, but 3 and 1 the other ones. Alright guys, probably one of the longest videos. There will be another video for exam 2, which is going to be quite longer. I'll see if I have enough time during the EYP to make that video. For now, have a look at that, have a look at your results, and yeah, see how you went. Alright guys, I'll see you in the next video. Ta-da!